Hello guys, welcome to my YouTube channel. For this video, I'm gonna show you a universal template to use RK4 numerical simulation method to solve differential equations. Actually, I really hope this video can give you some ideas to use this method to solve any kinds of differential equations. And especially when you are using Fortran to develop a really big computation model, I believe this method will be effective and will be easy for you because I have been doing this high performance computation model development using Fortran for a while, and I always use this method, and this method really saved my time and increased my efficiency. I know the audience background could be different, right? For example, you could be from physics, chemistry, biology, engineering, geography, whatever. But I believe this method will be working and will save your time. Okay, so before I walk you through the code, let me show you something in the PowerPoint. Okay, so this is like an integration of RK4. I mean, this also applies to the Euler method or RKF45. Okay, so always remember, right? Before you integrate the RK4, you need to have the initial condition when the t is equal to 0 and x is equal to x0, right? Let's just say this is the initial condition. So at the time step 1, when you just start working on this RK4 numerical simulation, in the Fortran. So you need to call the RK4 numerical solution. And at the same time, you also need to call the differential equation, just call them together simultaneously in the one time step. Also, don't forget at the step 1, you also need to pass the initial condition to the first round integration, right? So when you finish the first round of integration, you will get the result, which is t is equal to t1 and x is equal to x1. Okay, and when the first round is done, when the first round is over, you need to do the second round integration. Still the same. When the t is equal to t2 in the Fortran, call the RK4 numerical solution, and at the same time, call the differential equation, and don't forget to pass the result you get from the previous time step. So remember, for each time step, passing the initial condition, call the numerical solution, and call the differential equation, they should be done in the same time step. And this is the key point to design the RK4 numerical simulation method. Okay, and for the Fortran computation method, usually, let's just say if you are doing a really big computation model, I personally think you can, divide your Fortran codes at least in the three parts. The first one, the first file, you can call it as a main file, which is like you define all the key parameters. You can also define the time step, the maximum time there. And also you don't forget to define a loop to call the RK4 numerical simulation. And when you call the RK4 numerical simulation, in the second file, don't forget to call another subroutine, which is the one you use to define the differential equation. So these two things has to be done together in the same time step. The way why I like to do this is that just say for example, your computation model is kind of big. There are so many data. There are so many differential equations. So we know that, right? The Fortran is an old school programming language. So which means the Fortran doesn't tolerate the mistake, even single grammar mistake. But sometimes, when the when your model is big, sometimes you make some small, tiny mistakes. But the point is, if you organize your Fortran codes as this way, it is really easy to help you to find where the problem is. and also it will make your program looks your model and your codes look very organized. So I really recommend, this is my way to do, and I have been doing the Fortran uh, high high performance computation for a while, and this method really saved my time. Okay, and for the codes example, I just use a simple one. My background is about chemistry, so let's just say there is a chemical reaction which is called a sequential chemical reaction. X1 transforms into X2, and X2 transforms into X3. So the differential equation, I want to get the concentration for x1, x2, and x3 respectively. So the differential equation to get these three chemicals concentration is something like this. Also, for your own project, I know the differential equation could be different, but it doesn't matter. Use this method, it will be working. Okay, then let's go through the codes. Okay, here is the main file where I define all the important parameters and the loop that I use to call the subroutine, to call the RK4 a numerical method subroutine. You see here when the time is at the first time step, which is here, I call the RK4 a subroutine here. And when the first time step is done, don't forget to adjust the time step and the initial values for the next round of calculation. And you see, this is the main file. And for the numerical simulation file here, I basically just define the numerical simulation method. And don't forget that when your program goes here, you also need to call the differential equation subroutine, which I defines here. And you see here in this file, I only define the differential equations. For example, there are 3 differential equations for my project, but probably for your project there will be 10 or 20, whatever. But you can just dump all of your differential equation in this file, and I believe this will make your codes, your model looks really organized and looks really clean. Especially when there is a problem, you can find the problem. Okay, so basically this is today's video, and I really hope this method or this idea can help you a little bit, and can work for your project. Also, you also need, I mean, for your specific project, you can also change the code a little bit, because for example, it's like if for your project there are so many parameters, you can also create another file which is called the parameter file, and use some methods to get the data from them, and this will, and I mean this may help your own project. Okay, so I have run this. I have run this code already, and it will working. It will be working. So I will upload this code to my GitHub page, and hope this may help you a little bit. And thanks for watching, and have a very nice day. Bye bye.